I don't know. I think there's got to be a way to do it.
I think it might also be closed.
Get started here. Notice you have these sheets in front of you. We'd appreciate it if you fill out your name, your email and department, and answer some of the questions for us. We're going to try and pick these up by like 12:45, so if you could get those filled out early, we're going to do a drawing from them to win a free book. So have these filled out, and we'll come around and pick them up, either me, Julie, or Gustavo, or maybe a combination of all of us. Before we get started, we'll go around the room and introduce everybody. So give your name and your department. And I'll start. I am Mandy Peel, and I'm from Science Ed. And maybe we'll start at this table. Name and department. Sorry, Karen King.
David St. Physics.
Aaron Prowett, Professor Emeritus, Mechanical Engineering. Doug Steinhoff, Physics.
Use physics.
Corey Webber from Mathematics Education.
AJ Womack, Science Education.
Marcel Fudget with Science Education.
Frank Schmidt, Biochemistry.
David Owens, Science Ed.
Christine Casella, biology. Zee Walsh, Statistics and Measurement and Evaluation Education.
I'm Riley Glossy, Chemistry.
Judson, with Science. And off we go, and then
Dana Rin.
Control, Biology. John Schul, Biology.
Anna Furniture, biology. Stephanie Stone, biology. Sarah Bush, biology.
I'm Sam from Mathematics Education.
Xander DiRaggio, also math ed.
And I'm Julie Burke from Science Ed, and I get the pleasure of introducing Xander and Sam. We're super excited to have them talk about flow construction. I can tell by the number of people here, which is the largest number we've had so far this year. You guys are really interested in this too. Xandra and Sam just got one paper accepted on this flow construction model, as well as just submitted a grant, which I'm sure is a huge relief, through DR K-12 and National Science Foundation. And Xandra is going to show the picture. About the Santa.
Yeah, so I don't have kids. Well, I do. They're just furry and dogs. But yeah, so Santa at the mall, if you're interested, you can bring your dogs Monday nights for Christmas. So.
Awesome. And we're excited to have Sam also from Math Ed, and he has 2 sons and a daughter.
Yeah, so I don't have dogs, unfortunately, and we haven't been to see Santa, but I have 2 sons, and I wanted to share this ambigram that I designed with my wife. So if you have visual spatial skills, you can rotate it around and notice the symmetry. We just designed one for my other son, John, as well, so we're going to get it mocked up. And we have a girl on the way in the spring, but the name that we're considering seems like it's ambigram proof, so I don't know what's going to happen. I'm totally stumped on it, so it might just be something for the boys.
So, as Julie mentioned, we are working in flipped instruction. So Sam and I are both in math education, so we mainly deal with the teaching and learning of mathematics, and we're primarily K-12. But flipped instruction, as you know, has very much infiltrated higher education. And actually, some of the first studies of of flipped instruction were in university science courses. And then older studies on flipped were actually called inverted teaching, where they would send lecture materials home to read, and then in class you would do application. So it's been around for several decades now in some form or fashion. However, it has gained a lot of steam in K-12 recently. 2/3 of teachers have reported flipping classroom lessons using flipped instruction at this point. So most classroom teachers are actually ahead of research at this point. They know far more about it than we do. So Sam and I are trying to catch up and get some empirical evidence out there. So the first thing we want you to do, you've already introduced yourselves to the group, but at your table groups, we are K-12 educators, or studiers of education. So talk about what you know about flipped instruction. Have you used it? If so, what form did it take, and what do you know about it? Yeah, we make you talk to each other.
I would have Classes while I was entertaining questions on this subject, but I didn't do it in the organized way.
I think because no lecture, what do we do about English science stuff? She's like, no, I know everybody. Like, so you actually do.
Like you just expect that they know, and if they don't, then they just don't.
So when they were taking the classes, they were so used to having someone talk like first before they sing.
You try to do an evaluation of it, it doesn't, so there it doesn't work.
If that's accounting for something real, I mean, I feel ripped off, that people are getting away with not doing something. So.
I had that too, where I tried to get people to prepare ahead of time, and then if they don't do it, there's some people who are ready to talk, and other people they don't contribute, and so the people who are ready are upset that the other people aren't ready.
What class?
It's low. I think that we don't fully engage and do.
You just changed everything on it,
Yeah,
right?
No, well, yeah, I mean, of course you can do that in science as well, but and you found that the students just weren't really involved in that? They didn't want to take part as
they were happy to take part, but they had a hard time getting used to the idea of being initiated because they were so used to being told what to do.
Yeah, but last summer I taught both. I taught my online and taught my regular the top 20. But I didn't try because I didn't know how my online course would go. So next time if I teach top 20 in the summer, I have 20 students, I might have to try this approach. Yeah.
Okay, another minute to wrap up, and then we'll come back together.
Anything after 4 minutes. I think I really understand how complex. I'm not thinking lecture. So I don't think of myself lecturing and all talking and listening and
Okay, let's wrap up and come back together. So it sounds like just me snooping in on various conversations is that a lot of people have either tried some type of flipped instruction or, oh, the camera's like not following, huh? I don't think I touched anything, but we'll see. So people have tried some flipped instruction kind of techniques and things like that, and you want to learn more about what we're finding, which is great. I will encourage you to ask questions as we go through. This is a pretty informal presentation. We're going to share our framework that we've developed, and we've published several papers off of this work. And we're, as Julie said, we're trying to get funding for a bigger, larger scale study. When we think about flipped, a key characteristic that many people think about are the videos that are inherent with flipped in classrooms. So what are some things that you've seen used or that you've used for videos in flipped classrooms? Anything that you've tried?
I tried, but I have seen in high school classroom teacher talking about like how to do basic like calculation. It wasn't a physics classroom. Or taking notes, how to take notes. She was like letting students watch about like how to take notes, and then they learn about it when they're watching the notes. Or how to do graph verbs, that kind of stuff.
So videos on like some skills or something that they're using. Other things you've seen?
Physics seems very direct, and it's very just
Mm-hmm.
This is what force of friction this is what the normal force is. Those would be things that you could potentially pre-record the lecture,
Mm-hmm.
either a video or screen capture of the lecture.
Right. Yeah, that's really common, and in math, obviously, that's like a perfect context, many people think, for flipped instruction because so much of it is procedures and things like that, how we commonly think of mathematics, that offloading the lecture makes a lot of sense to a lot of teachers. A lot of Khan Academy videos have been used extensively in K-12 education. What we're going to show you today is a framework that Sam and I have developed and kind of used as an analytic tool for data, but also as a tool for teachers and educators to think about as they undertake and implement flipped instruction. So this kind of follows a framework that's pretty common in math education, but we kind of broadly construe flipped instruction as occurring in two venues, so the at-home components and the in-class components, and hopefully it ends up in student outcomes. And so what we're going to do is we're going to go through these various components, and all of our examples are going to be in mathematics. However, we think that it's applicable to science and beyond, and we've heard a lot of science classrooms, K-12 and college, are using flipped instruction. Our examples are going to come from 8th grade math, high school math, and college calculus. So what we're going to do is talk about some components in each of these frameworks for you to consider as you decide to flip instruction or not. Things to consider about videos, about what you're doing with your class time, etc. So we're going to start with at home. So traditionally, at home is where you assign your lecture, and usually that takes the form of a video in flipped classrooms. So what we found is that teachers do not have a consistent meaning for what it means to flip. There's no like unified model of flipped instruction. It has a lot of variation, which is why we've created a framework to capture the variation in it. So if you think broadly of at-home videos, so we're talking about videos, but we include multimedia. So some teachers have made iBooks or other PDF files of worked examples, things like that. You can broadly think about them as following into kind of like three things. So the video multimedia. Sometimes you just assign problems or exercises, and then sometimes teachers do no homework. So this is to capture what a lesson would look like. So maybe a teacher does this one day and then does something here. Another day she might do this and then something else over here, right? So this is the framework that we're working with. We're going to start by talking about the videos because that's kind of what everybody thinks about when they think of flipped instruction is the videos, and that's what we're finding most teachers spend their time with. Okay, so there's two types of videos that we've classified. One is lecture videos, and this is probably by far the most prevalent form of video. So the purpose of a lecture video is to present content. And like Karen was saying, like directly instruct on some skill, application, or idea. But there could also be set up motivation videos that we'll talk about in a minute. But first we're going to just talk about the lecture videos. So in terms of lecture, we think for mathematics there's three components that you should attend to when you're discerning the quality of those videos. So there's a lot of videos out there. I heard a derisive snort about Khan Academy. So like we're trying to figure out, it's my political way of saying, we're trying to figure out different ways that you could judge the quality. So teachers have a lot of resources. If you go on YouTube and search for algebra videos, there's probably like hundreds of thousands of hits. So how do you discern the quality of those videos? There's no standards right now, and there's no empirical research yet. So what we did is we took three ideas that we thought were the main components of a lecture video. So the mathematical quality obviously is very important for a mathematics educator or a mathematician. We care about the multimedia design. So there's, from educational technology, there's various components of multimedia design principles that we consider when we're looking at videos. And then we look at the interactivity of those videos. So I heard some group over here saying like the kids don't always watch the videos and then you have nothing to build on in class. Interactivity kind of gets at that because it puts activities into the videos that kids can do so that you ensure that they watch, right? So these are the three main components. Sam, do you want to add anything?
Yeah, so a couple details on each. So with the mathematical quality, In our subject area, what we look for here is we look for conceptual explanations behind the ideas. So it's very easy in mathematics to just explain a procedure. And what we look for is, do they conceptually motivate or conceptually explain the procedure rather than just telling you what the procedure is? We look for justifications and reasoning. We look for precise and appropriate language, content language being used. Those are the main ones that we look for. We also look to make sure that they don't just blatantly make a mistake right in the video. We look for unmitigated errors. So it's okay to make a mistake if you then address the mistake and say, oh, I'm sorry, that was a mistake, let me fix that. Or if you make a mistake on purpose because you want to later bring it up as, oh, look, that was incorrect, we need to correct it this way. But in some videos, there will be an unmitigated error where we think, oh, no, that teacher actually just made a mistake and left it in the video, and it seems like now it's there as a correct mathematical thing. So the conceptual development, justification, language, and absence of unmitigated errors. In multimedia design, we look for a few things. We look for organization of the space, like the screen space. Do you have things kind of well organized? Do you have things that are relevant or connected to each other, located spatially together, so that you can kind of draw those visual connections? Also, the multimedia design includes what's being spoken and what's being said. So if somebody's writing on the screen slowly and then just kind of speaking it as they're writing it, people watching it are just like, oh my goodness, is this going to go on for 25 more seconds? That would be something negative in the multimedia design. Or if you have a big block of text and then you just start reading through this entire text, that also would be a negative thing in the multimedia design. So things like that. Having lots of distracting, extraneous images flying around or coming in that are not actually relevant to the ideas, that would also be a negative thing. You would want to have relevant images or relevant images displays. And then interactivity, like Xandra said, that's an important one. Something that gets the student involved in the video. So it could be an embedded question. It could be that you require students to comment underneath the video. It could be that you pose questions to the students and say that they're going to have to bring their response into class. Something that the student, they have to actually do something while they're watching the video instead of just passively watch it. So we want to play a little, like a minute of this for you and see what your reactions are about the mathematical quality or the content quality, multimedia design, and the interactivity. And we actually are, we recognize there are a lot of science folks in the room, but we still think you can see what your perception is of the mathematics, and then if you're thinking about science, you would have similar things, similar criteria about the science content quality of flipped videos. But we'll play just a little bit of this for you.
Okay, in this video, I would like to talk about the area between two curves. So, I have two curves here. The top one is being the square root of x, and the bottom one being x cubed, and what we would like to find is the area between them. So, one way to think about this is that I can find the area under x cubed, so that's, square root of x, right? So this is square root of x, and I just find this area between the square root of x and the x-axis. That would cover, like all of this, right, over here. But I want to subtract off this part, which is the area under the curve of x cubed. And again, when we say area under the curve, up to this point we've been implicitly saying that that's the area between the curve and the x-axis. So one way to think about this is the area between square root of x and y equals 0. So y equals square root of x and y equals 0. Or we could think of this area as the area between x cubed, y equals x cubed, and y equals 0. So really we're subtracting them. So, to find this area, we would say integral from 0 to 1 of the square root of x. And for this one, we would find the area from 0 to 1 of x cubed. All right.
Well, yeah, you can guess. So then he subtracts the 2 and then brings that back over to that one. So right away, what did people notice either about the mathematical quality, the multimedia design, or the interactivity? Reactions to this snippet.
I seemed a little bored right at the very beginning. I was like, okay, well, here we go. And then it completely grabbed me.
Okay, so that could maybe go into the design of the video being sort of attention grabbing, that sort of thing. Yeah, I've found in my own videos, the beginning of the video is always pretty hard. Like once you kind of get into a rhythm, you can kind of go, but starting off can be a little tricky.
But if you start with something flashy, then your mind focuses on the flashy thing, and then the rest of it kind of just flies by. So if you just want to learn about integrals and how to think about them in area and how to subtract to get the area between two curves, then a non-flashy start might be better, because otherwise, like if a plane flew by or something like that, you'd be thinking about the plane instead of about the curve.
Yeah, so I think this is about the balance, and this would be, I would think, both under multimedia design, balancing this, that you want it to be enticing and look good visually, but you don't want it to be distracting. And that's a multimedia balance that you have to have.
I was actually kind of encouraged by the fact that it wasn't as perfectly manicured as some of the videos are that you see coming from a textbook video, for example. Because I found it really clear to follow, and yet he had mistakes that he had corrected. And
It felt like it was really him.
yeah, I was
right?
like, oh,
Yeah.
following along.
And he makes these videos for his own class, and so the class knows him, and then this definitely, you can tell it's him doing this. And so that's something you could think about as well, is like how much of yourself do you want to be in that video versus how much spit and polish do you want on the video.
But on the other hand, I think this video is short, right? But if you have longer video, you want to minimize the errors. Even if you correct them, maybe the student might, they still take actual effort to figure out like what's wrong, what's corrected, right? So if you, I don't know, I think maybe if the video is longer, I want the video to be as clear as possible.
That's a great point too. Like the
ones.
longer you get, the more risk you have of things just kind of adding up. So like the little, he misspoke briefly and then immediately corrected it. But if this is a 17-minute video and that means you're going to have 20 of those, that might be quite a bit. So that's one of our mathematical quality would be, he had a couple little minor errors, but he immediately fixed them. So that would be okay for us. We would take note of them. On multimedia design, anything else about multimedia design? So this is a camera pointed down, and it's literally just filming himself writing on a piece of paper. So in terms of how he made the video. But anything else about multimedia design? So the layout, spacing, tone of voice. Well, yeah, was the projector bouncing? Because in this room, the projector also happens to bounce all the time from anybody walking upstairs. So his video doesn't move. The camera is fixed, but the projector was probably moving. But you do bring up a good point, because at this, like thus far, he's used less than half of his actual space. And if you can't really tell, but actually this is just dark space here. This is just dark space here. So his screen is actually larger than his workspace is, so that's also wasted space. Later he will fill this up, and so you could think, okay, what's the trade-off? I'm kind of inefficient at the beginning, but maybe it's going to pay off later because I'm going to have the integral right underneath the area. I'm going to have the integral right underneath the area. So it's kind of like he's thinking ahead to the space, and he's going to do it all in one shot. But yeah, maybe it would have been better to have closer-up views of those curves and then go to a second shot where you have multiple things together. So that's the kind of stuff we would think about with multimedia design. We rank this fairly high, even though it's just a guy pointing a camera at a piece of paper, so it's very, very low tech in terms of how he made the video. We actually rated it pretty high on our different multimedia factors because he did end up with these nice equations, nicely organized and associated with the area, and then these ones connected back to that one. So we did think that he had a good organization to how he laid it out. And his tone of voice is easy to follow. He's not too fast. He's not too slow. There are these little things we've brought up, but overall, we had him pretty high. Interactivity, you didn't see any here. You wouldn't see any in the rest of the video either. This is just him presenting it. So you would just sit and listen or watch the video. Let's show, the next one. All right, everybody's favorite. So we're going to just watch like 1 minute of
Welcome
this.
to
Con.
the level 1 linear equation. Let's start doing some problems. Let's add the equation 5, big fat 5, 5x equals 20. So at first this might look a little unfamiliar for you, but if I were to rephrase this, I think you'll realize this is a pretty easy problem. All this is the same thing as saying 5 times question mark equals 20. And the reason why we do the notation a little bit, we write the 5 next to the x, because when you write a number right next to a variable, you assume that you're multiplying them. So this is just saying 5 times x, so instead of a question mark, we're writing an x. So 5 times x is equal to 20. Now most of y'all could do that in your head. You could say, well, what number times 5 is equal to 20? Well, it equals 4. But I'll show you a way to do it systematically, just in case that 5 was a more complicated number. So let me make this a little, my pen a little thinner, okay? So rewriting it, if I had 5x equals 20, we could do two things, and they're essentially the same thing. We could say we just divide both sides of this equation by 5, in which case the left-hand side, those two 5's will cancel out, we'll get x. And on the right-hand side, 20 divided by 5 is 4. We would have solved it. Another way to do it, and this
multiplies it by 1/5 is the next one it does. All right, so mathematical quality, multimedia design, interactivity, people's thoughts. Yeah.
Well, when he was writing the first numbers, I was going crazy because he's taking so slow, and the big font, and it's not like he's writing with a pen, he's like writing with a cursor or something, and it reads really jumpy and stuff. And,
Yeah, and why would he start recording it before he'd even put the equation there? Like, why not just have the equation on the screen and then start recording? And then, yeah, he actually seemed surprised by his pen tool. So, I don't think he even checked what pen tool he was about to enact. Students learning algebra. And we won't even depress you with how many views these videos have. But yeah, this would be for students learning algebra, like Algebra 1. They can watch these videos. He has, lots of them are just him personally have made them like this. And they can watch, all these algebra videos to learn the whole algebra curriculum. Like this, like learning how to solve one-step algebraic equations.
My granddaughter did this in 3rd grade.
Yeah. So let's stay on multimedia design. So we've got the kind of, it's literally like a mouse that he's drawing with instead of a pen. Other things on multimedia design people noticed.
It seems like he's spending a lot of space to say so little.
Yeah. Yeah. He's got all this so far and hasn't done a lot yet. Anything else on the design?
his cursor was bouncing around a lot, which was really kind of annoying.
Oh. Yeah, and while he's kind of just talking and waiting, he just kind of like shakes it around before he goes to do his next thing. Anything else on the multimedia design? Anything with his audio, like his speech?
I feel like when he tried to explain it in the second way by saying 5 times question mark, that's really the same thing he said when he did it the first time. So, I mean, if he could have presented it in a way that said, how many groups of 5 does it take to make 20, that would have been a better way of phrasing it.
Right. That's true, because he had already said what number times 5 equals 20, and then he's like, another way to think about this is 5 times question mark. It's like, not really another way.
He speaks too slowly. It's not a normal speech.
Because he has to, I think it's because he has to wait for his drawing to catch up with himself. At least parts of it, he's just waiting for him to be able to write out times question mark equals 20. And so he kind of vamps to fill the time until he's caught up.
Right, and that's
Has
also
he told his audience what a variable is?
in a prior video, I think.
Yeah, this is in a sequence of videos, so it's hard to get to that thing. But one thing that we did notice in this one is in mathematical, this is now going to the mathematical quality, he actually said, you can tell what this is, it's 4, right? So right there, he actually took away the motivation for the algebra. There's no reason we need the algebra because we all just agreed that this is easy to tell that it's 4. And he said, well, let me still show you the algebra in case you might need it on some other problem. Why not have a problem where the algebra is helpful? That might motivate it more. So that's getting to us sort of like conceptually, is he justifying or motivating this thing that he's trying to show you? We would say, no, he didn't really motivate it. He kind of alluded to a future motivation, but there isn't one here. So, and there's also no interactivity in this one. So we'll probably need to move. Do you want to?
So this is from an 8th grade teacher, and she's been flipping since 2011. And so she created iBooks. She was concerned about her students not having internet accessibility at home. And so she created iBooks. They're just books that are interactive and digital. And then the kids could download them so they didn't have to have internet at home to use them. But what we see here is she kind of made it mirror a traditional textbook in many ways, but she also did embed videos in it, and she embedded quizzes in it. So in terms of multimedia design, she scores pretty well in all her multimedia design. Her videos are very short. They're 8th graders, so they never exceed 8 minutes. And they're very clear and to the point. There are actually a lot of worked examples, but she has clear objectives, and then she has these embedded quizzes for some interactive features for the kids so that she makes sure that they're doing some work at home while they're doing it. So they're not passive viewers of this video. So this was kind of elaborate. She said, obviously, it took an enormous amount of time to make all of these because she did make them for every lesson, and God forbid she changes books because they're aligned with her textbook. But so that's another one. So in contrast to the other two, this one is very high in the interactivity. But it's also high in the mathematical content, was pretty strong. So those are the 3 features we were attending to in terms of lecture. Now, another video that Sam and I thought was actually a very powerful way to enact flipped classrooms and flipped homework was set up motivation videos, but they were pretty rare. So in mathematics education, there's a large movement to do more conceptual development of ideas rather than straight lecture, especially in K-12. It's kind of like inquiry in science, the movement towards that. So one way that teachers could avoid just lecturing at home is they could use these videos to set up some subsequent problems for the classroom and have kids think about some situations ahead of time and then expand upon them in classroom when all the brains are in one classroom and they can work in groups. So we do have 2 really, well, I'll only show one for the sake of time, but 2 examples of this. So in this first one, I'll just talk about this one and then I'll show you the second one. This plane, it's just a video of a plane taking off on a beach, and the teacher set it up by asking the kids to think of questions that they could answer using mathematics with this video. So the kids came to class the next day after watching this and came up with videos. And Sam, I think you would say that there was a mixture, right?
Yeah, they ended up coming up with questions about the angle at which the plane was coming in, and questions about how far above the people's heads was the plane, because there's this beach with people on it, and the plane comes right over them. And so they used some trigonometry to try to answer those questions.
Mm-hmm. So similarly, there's a former teacher that Dan Meyer, who's well known in math ed, and he makes a lot of these setup videos, and so you can kind of pose problems like this, where you just have students watch some stuff. And so on and so forth. So then you motivate this and you say, okay, so what kind of things are we going to investigate in class the next day? You could give them some ideas to consider to start sparking, like how would you answer these couple of questions, and then in class you can investigate it as the whole class. So in terms of determining video quality in these situations, we had a couple features, but like I said, they're pretty rare, so we haven't seen a lot of instances on these, but these do align a lot with the recommendations from mathematics education in terms of like how would you launch like a high cognitive man task that would have a good engagement and good discussion in class. So it should have a mathematical purpose. In the plane example, the teacher's question was very general, so the kids came up with things like, where's the airport? What kind of plane is that? Like, where is it going? You know, like things that weren't really mathematical in nature. So we said it depends on how the teacher is going to set up these videos and what they expect of the kids. It needs to be a clear purpose. But in science, I'm sure there's some applications where you could think of, like, you want to spark a discussion or think about a process or something, And so they can watch it, so everybody has a common starting point. They could bring in some questions that they can actually investigate in class or a lab. You can show them different colors. I'm thinking way back, like chemistry. If you're doing flame tests, for example, show them all the flames and stuff, and then in class you can talk about some of the reactions, and then they could have a common starting point, at least to see the different colors and stuff, if you don't want to waste time burning everything in class. So these were, like I said, less common, but they were pretty powerful when enacted well, right? Because the kids are not just taking in information, they're actually actively setting up for consequent activity, which will uncover the content in class through investigation, like a lab situation, rather than just a lecture and traditional practice by yourself. Okay, so what we found is that teachers spend an enormous amount of time building these videos, but the real power, we would argue, in flipped instruction is that you have all this class time with all these brains together that you can do application and practice, and teachers are not planning for that component of the lesson. So you're spending all these time, these videos are very labor intensive to do. So what we would recommend, I think, at this point is say, consider the quality of the videos that you have access to instead of thinking that you have to develop everything on your own. There's a number of good resources that are well made that are already in existence. Instead of spending all your time sending this thing home that you have a hit or miss chance of students actually watching, what you can really capitalize on is your expertise with students in application in the classroom. And that's really the beauty of flipped instruction in theory, is that the benefits would arise from the class time that you've freed up now to do interesting things, not just like traditional homework. So Sam's going to talk you through some kind of considerations for it, but again, what we're probably, I hope your takeaway is, the videos are nice and all, but I think that if you want to get the biggest impact out of flipped instruction, it's not going to come from the videos. And like an extra 3 hours making a video is not going to pay off as much as planning for your in-class interactions when you're there and all the kids are working together to support one another.
Yeah, that's one of the hypotheses we want to explore if we get funded from the proposal we just submitted. Because we hypothesize that if you make an amazing lecture video that's going to give you a marginal, hard-to-detect bump in any of the learning, the student outcomes on the far right. But we think if you have at least a decent video, and then you do some amazing things in class, we are hypothesizing that that is going to have some noticeable effects. We're going to be looking for correlations, but the hypothesis is that there might actually be effects on students learning from that. So for us, we're kind of disheartened to see how much time the teachers are spending on the videos, where they basically spend so much time on it that they have no time or energy for anything else. And they go to class, and they have all the students now with a full class period to do something, and they haven't even planned for what they might do. They're like, well, I hope they ask some questions, and then I'll just try to answer them. And so we're like, oh, no, that was your chance. You now have this whole class period to do something. So here's how we've been kind of structuring what we think the options are in class. And really this can apply to a lot of instruction, but we think you have particular potential for this in flipped instruction because of the extra time and because you can have some of the stuff happening at home. So we divided it into stuff you would do with the whole class, where everybody is attending to the same public discourse, and then things that you might do in non-whole class, so maybe having them work in groups or maybe having them work individually. That's kind of structurally how we divided it first. If you, as a teacher, decide, I want to do some things with the whole class, the distinction that we're making is between univocal discourse and dialogic discourse. So univocal discourse is somebody speaking to try to transmit meaning, and other people are listening and trying to receive that meaning. So like what I'm doing right now. I have ideas I'm putting out there. Hopefully you're getting them. It can be a student that's doing that as well. Like a student might be sharing their thoughts or their solution, and others are listening to try to receive what that student is saying. But it's a univocal form of discourse because it's just basically trying to transmit the meaning. But we think there can be high-quality univocal discourse and there can be low-quality univocal discourse, so these are the things we look for. Is the mathematical idea clear? Is there a justification given for the idea? And then some other secondary kind of features. Is the idea motivated? Are there connections made? Does the person univocalizing or the speaker, do they actually check with their receivers to see if any of it's getting through? And that, part of a good univocal discourse would be that the speaker is checking to see that it's actually being received. And then number of transmitters is something that we also check. Like, is it one person literally talking the whole time, which would probably be the teacher? Or is there 3 or 4 people that got to speak? It was all univocal, but there were at least 3 or 4 of them, or 5 or 6 of them that got to speak univocally. So we would look to see, okay, are they doing whole class stuff in univocal and with what quality? Sorry. I guess, yeah, the screen's throwing me off a little bit. So dialogic here. Dialogic is dialogue. It's multiple speakers talking with each other to try to develop a meaning together. So it's not that one has the meaning and is trying to give it to the other. It's that the two are talking together to try to make meaning. So you're pushing on each other's ideas and you're coming to a new realization together, or you're asking questions of each other, or you're extending each other's idea. And again, we look for, is a mathematical idea actually clear and present? Because one thing that is tricky with dialogic is you can kind of get off track and you can all of a sudden realize, whoa, we've been having this discussion, but I'm not even sure where we are. We're kind of all over the place. That would be a sign of poorer quality, where if it's actually going towards a mathematical idea, that would be higher quality. We would want justifications happening in the discourse, and then looking for somebody's idea that actually gets taken and say, like, hey, we're going to spend time with your idea and try to see if we can figure it out, refine it, clarify it, correct it. That would be high-quality dialogic discourse. We saw this a lot, univocal discourse. Dialogic, we saw a little bit of it, but again, it's harder to find, even though we think it could be very powerful, but it's harder to find. We think flipped instruction maybe gives you a little bit more of a chance to do that, because if you offloaded the lecture, you've offloaded the teacher just talking at the students. So now when you're together in the room, we can actually maybe do dialogic things and we can try to make the meaning together. That's what we think there's potential for. It's just hard to find it in the mathematics classrooms that we've been to. And then if you do non-whole class formats in groups, and whether you're having them work independently, here we're just using a common framework from mathematics education to look at the cognitive demand. So what are the thought processes that are entailed in the work that you're asking them to do? Is it high-level things like they have to problem solve and reason, and they have to make connections between ideas or explain the reasons behind ideas? Low cognitive demand is more like execute a procedure or just recall facts, memorize the stuff that you need to memorize. So there, again, whether it's group work or independent work, one of the things that teachers have said for a long time is the reason that they don't do high cognitive demand tasks is it takes way too long. Like when I give them a real problem-solving problem that they have to explain and reason through, I'm going to lose the whole hour and we're still not even going to get it finished. It would be a lot faster if I showed them a procedure and then I had them practice the procedure, which would be low cognitive demand. So they've really said time is a barrier because it takes longer to let students really dig into the problem solving and the reasoning. But we would say, well, in flipped instruction, you've just bought yourself some more time in class. You can have people working together. You can be there as a teacher to facilitate it, and you can make it through the challenging high cognitive demand things. So we're hoping that teachers, when they flip, part of the reason they might be flipping is so that they've bought themselves an opportunity in class to do high cognitive demand tasks. And we did see some of that. We have more data on that than we do the dialogic discussions. So.
Yeah, so I think overall what we've seen is that we've seen teachers that started flipping because they wanted to go more deeply into mathematical ideas and they wanted kids to be more critical thinkers. And so they decided to offload lecture, which could be offloaded, right? So that's something that you don't need a professional teacher to do. You just need a script and you could do it, right? And they use the work of teaching to actually engage students deeply. But what we're seeing is that they're not doing that because they're putting so much time and effort into these videos and ignoring kind of the plan that is required for the in-class activity. Some of the teachers expressed concerns that their flipped classrooms were turning into kind of like what they called emporium models, where the kids were just working on their own pace in class. And I think if that's the case, then I don't need to be a highly qualified educator to do that, right? So one of the fears with flipped instruction is that it could deprofessionalize the profession, because you're just giving videos prepackaged and then the kids are just working at their own pace and I'm like a tutor. That is not probably what we're guessing is going to be the most impactful. It's going to be like you need to have more expertise in education to facilitate that in-class time well than you would in a traditional class when you're just lecturing. Because lecturing, you could prepare in advance and be have a really killer lecture, but your pedagogical content knowledge doesn't need to be as high as it is in response to student thinking and actions that happen in groups and things like that. So those are the kind of things that we've been thinking about. Like we said, we're going to hopefully get funding to do a study on a larger scale so that we can see some correlations if they exist in terms of students' knowledge. And then the next step would be to do some quasi-experimental studies to see if there are any effects. But we're happy to take questions. Yeah.
So this is the kind of new notion to me because I'm so old. But you wouldn't say you have a textbook and we're going to talk about Chapter 3, Section 1 on Tuesday. We'll work some problems. That's not, nobody said anything about a textbook.
Yeah, so you could do it in that way, and it's it would be a form of flipping. And how we're seeing it with teachers, they're not considering that flip necessarily because they're really monopolizing on the multimedia aspect. But I would argue that's very similar in intent, right? So if you think of the content delivery phase and the application phase of a lesson, you're offloading the content phase to the home and then the application in class. So I think it's really similar. And some teachers, the teacher that made the iBooks, she did start by flipping with the textbook exactly how you just said. And then she moved on to videos after that because she thought the kids would be more engaged.
So it seems to me the model draws on a particular concept of lecture, which is sage on the stage model, where, in fact, and I would guess most of us in this room don't lecture that way. We are always interacting, we're always posing problems, we're always expecting students to do things in class, rather than just sit there and babble on about our subject. So, looking at this, I would have to say, what are your two cases, right? You're hypothesizing that flipped is better than straight lectures. And the question is that the opposing case you need? Or is it, if I were to look to put this in, I would have to be convinced that flipped is better than the way I lecture.
Correct. So that's why we've done this. So we didn't want to just say flipped instruction. That's why we've had these quality components to capture variation. So this would be like lecture like you're talking about, right? So univocal, like we said. But we're not just saying any direct instruction would fit into this category. We're actually categorizing by is it an effective form of that? Because in any case, explicit instruction or dialogic instruction, there's going to be high quality instances and low. And what we found in the literature so far is all of the studies that do exist on flipped pit flipped instruction against some other instruction, and we have no idea what they mean by either. So we're trying to capture the nuances exactly for the reason that you said. We agree. I think a high quality lecture that has interactivity and stuff against a high quality flipped, I have no idea what the outcome would be. But I think a high quality lecture versus a poor implementation of this or vice versa would definitely have differences, of course. So yeah, we developed this to have a more nuanced explanation of both the non-flipped and the flipped classrooms.
Yeah, the first few small empirical studies all framed it as non-flipped being compared to flipped, and we really don't want to do that at all. We want to basically say, how are you flipping? Are you using lecture videos? Let's look at your lecture videos. What kind of lecture videos? Do they have interactivity or not? What are you doing in class? Let's distinguish between that. And so now we're not really calling you a flipped class. We are calling you Mrs. Williams' flipped class, where she uses a high-quality mathematical video with interactivity, and then she uses independent work with low-cognitive tasks. So we really want to talk about Miss Williams' implementation of flipped instruction. We don't want to really talk one versus the other, because like Xandra said, we could find a great in-person lecturer that can beat a poor flipped class. We can find a really good flipped class that will beat a poor in-person lecturer. And so we're sort of like that. Neither of those is really very important for the field to know about.
Right. And our study that we proposed, we're looking at the different outcomes, the different parts of flipped instruction and the different models of it and how those might correlate. So is a high-quality lecture coupled with this relate to more or greater student outcomes than, say, a setup with univocal and things like that. So we're making profiles of classes using this so we can capture the variations that you're talking about.
And one really big implication is if somebody has a technique for lecturing in class where it's kind of this interactive lecture, if I ask pointed questions at certain points before I go on and that spurs the next part of my lecture, a big question would be, could an instructor like that translate it to videos, or is there sort of no way to translate that to video? We would want to know that. Are there some interactive features of a video that can sort of mimic or emulate the interactive things that you do during a live lecture? Those are interesting things to explore. What we see right now is even people who might be interactive if they were in a room with the people, when they go to do it in a video, they just lose all that and they just end up kind of telling it like Sage on the stage. Yeah. Sage on the screen.
I'm curious, how do you, I mean, you have a column student outcomes. How do you decide what they are and what they should be?
So, because we're doing in K-12 and we're doing high school algebra, we're using standardized end-of-course tests in Missouri for one measure, and then we're using a more conceptual measure that was developed by a colleague here to measure. So we're looking at algebra learning outcomes.
Does the model, I mean, it seems from the presentation that the model sort of assumes that student outcomes are primarily determined by what the instructor does in terms of designing at-home stuff and what the instructor does in class. But I'm wondering about the influence of student culture and student behavior. I mean, in the first minute when you ask us to talk beforehand, I think the thing that immediately floats to the top is that some students participate in the stuff that you assign before class and some don't. And that it seems to be the case whether you use a video or whether you use a textbook. I mean, in a sense, that's a flipped class model that's been used for so can you just respond to that or influence of the student?
Sure. So we're trying to capture some mediating factors between the various phases, and so we acknowledge that students may or may not watch the videos, and that will affect it. So we do have some measures like survey measures and things like that where we're going to try to get at what the students are doing. So do you skip ahead in the videos? Do you watch them straight through? Are you distracted while you're watching them? Things like that. So we have survey data from our pilot study that said students do flip around a lot, or are they doing other things while they're watching?
Or they're not watching.
They're not watching at all because the view counts don't even equal the attendance of the class. So yeah, we have added those into our model as well, and we're accounting for them in our statistical model.
It seems like the interactivity part of it could play a big role if there are prompts within the video. Those students have to actually answer them, and you could see whether they watched the video or whether at least what they answered. I don't know if you have some that you've seen that you could share. I wonder if people would be interested in a program or a site that they could use that allows you to embed prompts into the video. One that I've seen is called Edpuzzle.
Actually, yeah, I do, sorry.
Yeah.
But I was using Edpuzzle, and I just learned now that Canvas, you use Kaltura, which is embedded in Canvas, has embedded video feature that we just added.
Huh.
Whether it allows you to put questions
And we all are going to be moving in Canvas, so it allows you to embed questions, and then it will read it automatically right there.
But students are smart and they'll find ways around it, you know. Like when I have to watch security videos or at the zoo, right, or wherever I used to work before.
You're on camera.
You just have the computer with the video running, and then you have your other work. And then whenever the computer stops speaking, then you turn to it and then click the button and then go back to your other work. And students must do that too.
Yeah, and we're finding that the teachers, a big concern of them are students watching. But they said it's just like when I teach non-flipped classrooms, the kids that do the homework, and the kids that don't. So they said it's similar. We have had teachers try to make video quizzes to try to see if the kids watched, although they were slightly misguided in many cases because they would be like content quizzes. And if you just are checking to see if they watched it, you should probably just say, like, what word did I scream out in the video or something like that. Like, but they were actually asking math questions that related to the video, which kids could get wrong and have watched it because they just didn't understand what they were watching. So there was a misalignment there. But you're absolutely right. It is possible that students are not watching. But there are some tools, like Corey was saying and Karen was saying, like Zaption and Edpuzzle. And I know you've used other ones.
Now play positive.
I'm behind. So yeah, there's things like that. YouTube comments, you could make them leave YouTube comments. Again, that's no guarantee that they're going to watch or anything.
Mastering
So.
physics is now, if you talk to your peer student, if you have mastering chemistry or whatever, they're hearing this and starting to embed videos in some of the textbooks. Questions embedded in it.
Yeah. And a lot of the teachers didn't want to use those because they were like, it's not personal to my students, so they were spending all this time making them when really, in many cases, they would have been just as well off using those videos. But.
And we could be wrong about that. Like,
yeah.
We might find out, if we get to do the larger study, we might find out that the teacher making their own video has way better correlations with student learning than somebody else's video, in which case we're wrong and we'll eat crow and we'll tell them, no, you should spend time making your own video. But until we know that it's really worth the time, they were spending a lot of time making those videos.
Lots,
so.
yeah.
Maybe last question.
When I think of kind of STEM educational reform, then I think of it as that the content that we teach should change. We should go away in biology from memorizing the facts to understanding principles or that. Maybe in math, this is from algorithmic learning, how you solve this, to understanding what is going on in there. And so I'm trying to make a connection how flipping helps or does it lead to more less algorithmic, so more integrated or whatever learning, or is it just a different way of presenting the same things? Then I don't think it would be much of a gain there. So what they normally do as homework during class, okay, then I help them there. Otherwise, their mom helps them. But so how does this relate to this kind of bigger thing of how we're going away from memorization to that?
So, like, if you are who you are. So how you've been teaching, like when I was in the classroom teaching, I taught very similarly for 5 years, and I might have tweaked some things, but at the end of the day, I had a style of teaching. If you tried flipped, there's a good chance of from what we're seeing is that like you're just going to do that, but like with a video. It's not like you're going to magically change what you're doing. Your textbook didn't change necessarily as a high school teacher. So you're really using the same problems the same way, just like flipping the venue that it's occurring. So it's not magic, right? So, but we did see certain cases where the barrier to them implementing what they really wanted to do was time, and they felt like they had to do some direct instruction and they couldn't do it in the current format. And that's when we did see the flip actually yielding changes to practice. And we don't know if it was better or worse, but we did see them doing more investigative kind of things in class that were not algorithmic, because they felt good about that because they could still do the algorithmic stuff on video. So it was like freeing them up because they felt like they were doing their duty to the like memorization aspect at home, and then in class they felt like okay with doing it. So, well, I think we're out of time, and I don't want to infringe on the next class.
We've got a class coming in, so thank you very much for coming.
Yeah.